My name is Brandon and this is Frank, and we're going to share with you today a project we worked on almost a year ago, last spring, that really consumed 2 weeks of our life. That was an interesting problem from the aspect of that we work a lot to use computational tools for design and form finding, but this was also an opportunity for us to use those same tools and skills in a very real application as simple as sun reflecting off a building and hitting another building. So as we go through this kind of overarching theme, is just a reminder that this skill set is applicable not only in initial design and form finding, which we tend to use that for, but also in other subject matters where you're in basic analysis that you're trying to solve complex problems in an efficient way. So if you're from this area, you're probably already very familiar with the Natural Sculpture Center. About a decade ago, the Beck group, along with Renzo Piano, were the architects and contractor of this facility. Pretty small facility that consists of art galleries, interior art galleries, as well as a rather large sculpture garden, but very subdued and beautiful because of that aspect. Here's a picture of the interior galleries, and one of the things that makes this museum especially unique is that when Ray Nasher was working on the design in conjunction with Renzo, he requested that Renzo, in his gallery, he wanted to see the sky, which was kind of a difficult proposition because of the southern light that could be a danger to the artwork as well as the sculpture. So what they did is they developed a customized cast aluminum oculi system that would then be covering the roof in a smaller module that would specifically block northern light. Here you see it from the top across the vaulted roof. And here are the oculi themselves, so they would be specifically calibrated to block all southern light and allow only the northern light. Well, when you place them together in a small module, you have a clear view of the sky. Here is one of those individual pieces in the background of what it's doing. And here's the scale, about 3.5 inches by 3.5 inches square on each one. So within the last year and a half, when the museum tower started to be erected, they immediately realized that this could be an issue. The tower is a site plan which sits directly north of the interior portions of the galleries, and as well as the garden. This was a site that was somewhat contentious when they were building the building. I think Renzo actually suggested to the city probably 12 years ago that this site should be reserved as a park. So knowing that there could be issues of light reflection and wanting to stop that. But anyway, about a year and a half ago, the glass started going up, and immediately we started to see problems as the interior galleries then became this. So this is a very intense situation where the light is being spread over the galleries. Currently, they have put a temporary film over some of these spaces and have moved a lot of pieces out into other museums for temporary holding until this solution. They can find a reasonable solution with the tower. They also brought on Garrett, who was our original structural and mechanical engineer on the project when it was built, to do some analysis for them to find out what was happening as far as heat gain for their garden, as well as the interior gallery. So you see analysis that was done initially before we were even involved about how the light was going to, in a general sense, reflect off the building. Looking at the glass, which 44% reflectivity is on the high side of what any building would use for their glass. This is about when we were called to get involved from the client, and they came to us requesting, saying, okay, we can very much understand in principle what is happening. The sun's hitting this building and coming into our building. But what we don't understand is the technical nature of it, where and when and how this has happened. This building, I think it's appropriate to the next slide. As you can see, that with their garden, once you just take the sun, it could be an appropriate situation, but adding another percentage of that sun could start to have negative effects on your facility. So this building itself, with the, here we go. the shape of this building, if you're familiar with it, it's curved in plan on either side and also has a taper as it goes up, and has over 1,000 unique 4.5 foot by 12 foot tall panels that all cant backwards as well, so it has a shingling effect. So every single panel on this building is oriented in a different direction, and therefore will have a different reaction when the sun light shines on it. So our task was to try to analyze this information in a short period of time to provide the client a more explicit understanding of the problem that they were going into as they were preparing to have discussions with the group from the museum tower. So our job was really to analyze this and provide them with a basis of knowledge for them to move forward. So along those lines, as soon as we put our heads together, our first thought was like, all right, so there's many routes that we could take in order to solve this problem, but any of those routes that we need to take, we know that one thing's for sure, we're going to need an accurate model of the building. So one of the first things we did is call up a local laser scanning crew and sent them out to scan the building so we could get accurate information for as-built on how these panels were forming. So step one of the process while we were still putting heads together, trying to figure out what we were going to use. We then went through a process where we looked at several systems and tried to evaluate what was the most appropriate system to use for this problem through software. While many of these systems like EcoTech had the capability to solve the problem, they weren't maybe as appropriately suited as others might be. So while some of my reflection of EcoTech makes sense that we couldn't maybe customize the granular information that we needed for that problem. So as we went through looking at Ecotech as well as Grasshopper, and Grasshopper was a good example for us to quickly mock up potential ways in which we're going to understand these reflections. But considering all of the unique instances for all the panels and for the amount of iterations that we have to run, calculations, that feeding information back into itself in Grasshopper just wasn't going to work as well as we had hoped. But it did help us very much to really design the algorithm that we were going to use. And then ultimately decided on scripting specifically with Python in order to run through these millions of calculations at intervals in a day to really seek out what was the worst case condition for every window on this building. So I thought this picture was pretty amusing of like the traditional method versus where we are now of the Heliodon. But reconstructing basically the digital sun path within Rhino, so then we could use those paths to generate points in which we were going to study this building throughout a day, which we just take those paths and break them down. And as we subdivided the day, we needed to be very specific on what points in the day were going to be the worst and what points of the day were just bad situations. So we had to base all of our calculations based pretty much the worst case scenario across the entire year. So every panel had to be calculated for a certain interval of the day across the entire year, across every peak panel, studying both a condition that affected the interior gallery and the garden, as they have different areas and different relationships to the existing building. One thing, if you've ever done reflection studies, is understanding that you're going to have to calculate a separate angle for shading systems as they relate back to the normal of each panel. And so, again, having a unique angle is going to give us a tremendous amount of data. Again, studying not only the horizontal shading angle, but the vertical shading angle for each one of those panels. So essentially, we went through this process, and we were all, aside from doing a few mock-ups, this was kind of our brainstorming effort of understanding that we needed every instance on this building is going to have unique attributes. And we wanted to get to a point where we could have some type of collection of data for each one of these unique panels, if you would, that we could ask a question and get an intelligent response from. So Frank is going to kind of take us through the next portion of the presentation.
Yeah, so sort of like we had these nutrition facts, I guess, we wanted to come up with a way to sort of describe a curtain wall panel in a way that is not really particular to Rhino or Revit or any kind of particular platform. We started the process of writing a routine to just collect the information. We tried a couple of different things. This is sort of like what you would see in Ecotech, where there's like a blast of many rays at a target. We tried this and immediately realized that it was not the over, and came up with a much simpler and less intensive way to do this, where we would just focus on shooting a ray at the middle one panel. And so this made this a feasible process to move forward with. This is sort of what one day might look like. I think those are maybe like 15-minute intervals. So a lot of time. It's worth noting, if you look back at this slide, when you do this with every panel, you sort of get the effect of, if you look at these points going around the path, that sort of resembles the building side. So how do we measure the horizontal shading angle and vertical shading angle? So there's planes that are applied to these curve wall panels, and then we just make the measurement. So this is a lot easier to do than to try to do some sort of calculation. Just it's easier to make the thing and measure it. We also were very hopeful that we would come up with a really slick, clever solution for the problem. We tried a lot of things, like this is least amount of square footage of a louver system, but this is just for one day. So when you expand this across all the days, you realize there's not a great solution for this problem. Here's another example of that. So what we started thinking about doing was to bring this data that we're collecting out of Rhino into Revit. We had a guy at a job site that had some time named Kelly Jones who helped us make a family for Revit that we could place programmatically using a lot of the same code that we used originally. So this would be something that we could say solve for consistent spacing, vary the depth, or keep the depth the same and change the spacing.
I think it's something to note. I don't think we ever really planned or truly entertained having a horizontal louver or vertical louver option, but those were the most simple interpretations of angles that we could use to then make other judgments and explain that to the client. So that was the thought going into something just to create simple horizontal and vertical.
Yeah, a lot of this is to demonstrate to others why why this solution won't work. So just a little bit about like the technical process of this. Back to the nutrition facts type of thing. We start with a really basic description of the thing we're describing. In this case, it's a curve wall panel, and it's got corners, and it's got a middle, and it's going to have a horizontal shading angle, a vertical shading angle, and there's nothing really about either of the platforms that we're using that's in that description. And so that lets us use that same description to make the measurements and calculations in Rhino, and also we use the same description to then bring that information into a parametric family. Now, why would we put this in Revit? Here's sort of, this was
Hours of calculation.
very quick and dirty, and so we just stored these things in a text file. So here's the family. Here's this guy's desk in the trailer. You'll see a lot of people using Python to place like adaptive components and things like that in Revit. And placing a family like this is a little bit more complicated and can be frustrating. So what that gives you basically is like a visual database of these panels that has all the information in it. So you can start to ask the panels about themselves and represent them in different ways, like a grading of color based on a different value, or which is better for this panel at this time, a horizontal or a vertical louver system. And we did a lot of experiments. Like I said before, we were very hopeful that there was going to be some sort of clever solution for this. It was also good for demonstrating how poorly one of these solutions perform. I think this is vertical louvers, and we let the depth be whatever it needed to be to block the sun. So this has to do with how close the building is to the natural and how direct the ray would be. So pretty not feasible. I don't know what Brandon.
Yeah. Well, then trying to digest information is something that we could present to clients in a coherent manner who were very aware of the problem and understood, but were not technically minded, who we had to explain to them in a very simple manner. So ended up just simply breaking that down into the portions of the building, or pretty much the entire facade will shine on your side. There's a portion that only shines in the garden, and there's a portion that will shine in the garden as well as the interior galleries. So it's specific to note that. And so, and one, we continue to search for solutions that could mitigate both the problems, is because there was a real issue, like you saw in the gallery, but also there is anticipated, we'll know a little more when we get to this summer, but anticipated heat gain and breakdown of the plants in the garden once we reach our summer temperatures. Here's a quick time lapse from an iPhone on top of the miniature. So you can see the movement across the building has that similar kind of high right to low left pattern that you saw of where the sun's going to stop shining on the interior galleries and start shining on the exterior galleries. And what's important to note, so this is just one day's time, is that we're describing over 1,000 panels, and some of these panels, 99% of the time are not participating in this problem. It's for a very select time on select days throughout the year. So any type of fixed solution is going to be a pretty extreme investment when the majority of the time you actually have no need for any kind of mitigation. So that led us to look into dynamic solutions, but then we had using the same kind of bones for the script, went through and asked this building, all right, so when do these need to be active or inactive? So we were able to run through very quickly and ask the building to basically paint itself when these needed to be protecting and when they needed to be, or we could find them to be under any conditions. So this would be summer solstice, and you can see how it went pretty high at the low. Equinox is slightly different, and then throughout the year changes based on that. So as you can see, even just after the summer months, the top penthouse, $10 million penthouse tenant is not going to have these things, anything needing to mitigate the apartments a select amount of time each year. Just for reference, the winter stays pretty much primarily at the bottom of the building. So this was an opportunity for us using pretty much the same bones as in the coating of shoot this panel with a ray. If the reflection hits the side of the building, then change that panel's color and ring. And so could very quickly move from something that's outputting angular data or locational data to taking a picture or a screenshot. And it was information that our client could understand very easily. And that brought us to looking for dynamic solutions. This is a building I visited in Germany. This is an automated, almost roll-type louver system, stainless steel, that can be programmed to operate either on amount of total sunlight, or could be programmed on a timing system to be deployed. You can see here it's a very beautiful system, and it was interesting to go to the the manufacturing plant and actually watch the guys assemble these and put them together, which is kind of the very real aspect of what we're doing. Is we can mess around with calculations and showing you the pattern's going to be, but until you really go and understand how this thing's going to go together and fit on the building, it's kind of all for naught unless you really understand that aspect of the product. So here's the existing facade, the proposed added housing for the shading system, and then the appropriate deployment when it needs to be deployed. The existing curtain wall system, which conveniently happened to have a shingling, like I said earlier, to make a cavity for where our unit would go and be connected and anticipate easily waterproof up under that system, and then deployed when necessary. The end result being a dynamic facade that would change throughout the day as well as throughout the year. Could be an interesting development on this program. You know, we're not the architect for this tower, so we're always trying to respect as much as possible the character of the design, but also provide a solution that will be workable and reliable. Kind of wrapping up, so you see that although this problem is not necessarily like a form-finding example, we did use these same tools and techniques in order to solve a problem that was very much a threatening real-world problem. So I encourage you to be exploratory throughout your work, whether you're using these tools to design buildings or to analyze your designs or other buildings. It's very useful, and stay curious about all the things that you can do and how those things move across several platforms. Does anybody have any questions? But I don't know where we sit on time. I'm trying to hurry.
Did the fact that the individual panes were tilted and it wasn't a smooth surface, did that have any real impact on, you know, resolving the issue? I mean, if it had been a smooth surface, ostensibly it would have been sort of relatively similar, just a different pattern. Is that it?
The canting backwards at each panel wouldn't have really changed anything. The calculation would have been unique in its own right. It just changed maybe the time it would need to be for mitigation would need to be there for about maybe 10 minutes, and because of the sun moving so rapidly through the sky in terms of angles. But you know, one of the biggest things was that the facade is curved in point and also in elevation. So think about it, just a flat building, it's going to have parallel rays coming off of it, pretty much parallel. So basically, not too dissimilar from the Ecotech image you saw, a beam of light coming and a beam of light coming off. So once you actually start to rotate that, it creates more so a disco ball effect, where these are scattering out across all of the land in front of
So is that tapered and convex form the least ideal in terms of like if you had to go back and re-engineer the building, you could make a concave facade or something.
Yeah, but you would almost consider that a concave facade would be actually worse, because then you're focusing
right
on that sort of thing, which a lot of buildings have issues with that. Once you did the other way, it'd be basically a ray gun shooting a single spot. So be aware of that when you're doing concave glass facades, that you're not using a percentage of glazing that will then magnifying glass your site.
This form did it present additional complications just by virtue of the shape of the building, or it's just a generic problem that...
For the calculations, it didn't present additional issues. For the mitigation solution, it did. Because then each individual component has to be unique in its instruction or its list of commands of when to be in use.
The mitigation solution that you guys have determined, is it only reacting towards solving the issues of the art gallery, or is this also creating harmful rays to other surrounding issues? And you know, if you guys kind of implement this system throughout the year of operating, will that next year be like, oh, you're watching out this other building, or this other window which is really awesome?
Yeah, that was constantly in the back of our minds. It's like, who's going to pick up the phone next? One thing we did notice that when we were doing our radiation studies, and we had a local CDC, who's a local curtain wall designer, helped us do radiation studies, and we found that we were very much susceptible to it because of our adjacency to the building. Once you moved away, it actually started to decrease. But you know, a few blocks away, there was actually a building that we designed a few years back, an office building, the Hunt Tower, and with automated Mecco shades that were meant to, on the north side, or on the east side of the building, they were down in the morning while the sun was up, and then when the sun moved around the building, those went up, and the west side went down. But they pretty much had to override their system and just shut all the shades all the time. So yeah, it is could potentially be an issue. The one we proposed, and the one you saw was based only on the adjacent natural site. But you could certainly add calculations for when that would need to be extended if need be to other components. But then at that point, you're going to maybe get in a situation where during a sunny day, a much larger portion of the building is covered.
Jim?
Arm and Glass is a big subcontractor that can install it. And so we continue to work with the same people who had worked on this building to develop an estimate. In our preliminary estimates for this particular solution on this side of the building was about $7.5 million.
I was just curious whether a solution which would involve retrofitting something to the Nasher was considered instead of retrofitting to the Virginia.
It was, and conversations still continue. We were asked by our client specifically from the museum. They said, hey, we don't just want to know what needs to be done to their building. We want to know if there is a simple solution that we could do here to solve the problem, then we need to be considering that. We did look at several options that could, and are still looking at options that could potentially mitigate for the gallery spaces, but the odd man out always seems to be the garden. So aside from putting a large canopy over the entire garden space, you're going to be neglecting that component of needing. But to answer your question. Steve? One more question? One more?
You engaged by the gallery space to come up with a solution. Did you guys partner with whoever was building this tower, or is it around? Were they open to building a useful layout of the building? Or?
There were many discussions. It was very segregated because there's a lot of finger pointing, which there continues to be. Who is at fault here versus we were an existing building and we have sort of rights as that in terms of you can't dump your unwanted sunlight onto us because you want to maybe have a more sustainable building. And the other saying, well, there's no code requirements that say we can't build a 44-story building with 44% reflective glass. And so there was, each side continues at this point to research potential solutions, and sure enough, each side the discussion is researching for the opposite mitigation. So I think the key variable in that is the garden. That is the big game changer. Can you get something that can effectively protect the garden? I don't think that is, at this point, our research shows us that that's not practical. And so other than that, the most practical thing is to stop light immediately before, immediately after it hits the glass, before it has a chance to sway. Well, thanks for having us.